Now we would find out t square, the t-test. So for calculating the t-test, let's understand the formula. The formula remains the same as we did for the t-test for the sample, for one mean sample. So here again, the formula remains the same. The only thing is what is taken into account is the observed sample mean difference. It's not just the sample mean. In the case of one sample mean, we simply took the sample mean minus the hypothesized mean divided by the standard error, which is standard error for the sample. But here what we are taking is a little different. We are taking SD and x bar d, which is the observed sample mean difference and the standard deviation of the differences. So how do we calculate the observed mean difference? It is the summation of all the differences divided by the total number of differences. And what is the difference of the standard deviation? The difference of the standard deviation is the root of the summation of square of the differences divided by n minus 1. Clear? Now again, the same thing applies. If my p-value lies within the significance level, if my p-value is here, then I would say if my p-value is less than or equal to alpha, I would reject the null hypothesis. If my p is greater than alpha, then I fail to reject the null hypothesis. Clear? So that's what we understand here. Now, I have the scores of quiz 1 and quiz 2 conducted on the same students, and I have the data for 9 students. I calculated the scores. Okay. Now, how do you proceed? First of all, I find out the difference between the scores. Since it is a paired data, I would find out first the difference. Then I would find out the mean of this difference. Okay. So I would add all these differences. So summation of xd divided by n, I would sum all these differences and divide it by 9, and that gives me the value as 1 by 9. Now what I would do is 4 minus 1 by 9, 2 minus 1 by 9, 3 minus 3 by minus 1 by 9, 2 minus 1 by 9, and so on and so forth. So I get this value. Then I would square these values. Then I would again sum up these values. Clear? So what is my standard error of the standard deviation of the differences? How do I calculate it? Standard deviation of the differences. How do I calculate it? I have all the values here. I sum up all these values. Okay. I get 54.889. Now I divide it by n minus 1, which is the number of students minus 1. And I solve it. So my standard deviation of differences would be 2.619. Now t is the mean of the standard error, the mean of the difference of the observed data minus the hypothesized mean divided by this SD divided by root n. So here this value is how much? The mean of the differences is how much? It was 0. Okay. So this is 0. So I don't subtract anything here. Now what I do is I take the summation of the differences. So the summation of the differences, how much was it? It was 1 by 9. Okay. Now this value, since it is 1 by 9, which was the mean of the summation of the differences divided by the total number of items, which was 1 by 9. So in the numerator for the t, I have 1 by 9. The denominator is the standard deviation of the differences, which is 2.619 divided by root n, which is again 9. I solve this, I get 0.127. Okay. My degree of freedom is n minus 1, which is 9 minus 1, which is 8. Now, when my degree of freedom is 8, at 95% confidence level, I calculate the value and I get a value which is approximately more than this. So my t value here is more than the alpha value. So my p value would be more than the alpha value, and that value is higher, so I have p greater than alpha. Since my p value is greater than alpha, what I can say, when I am constructing a t-score at 0.127, I get my p value greater than alpha. So my alpha was 0.05, my p value is higher than that. That means I failed to reject. When I failed to reject, what was my hypothesis? My hypothesis is that there is no significant difference between the scores by the two quiz. So when I fail to reject it, I say that there is a significant difference between the scores of the two quiz, or there is no sufficient evidence to prove that there is no significant difference between the scores of the two quizzes, because I have insufficient evidence to actually reject the null hypothesis. So what do I say? That there is no sufficient evidence to explain that there is a significant difference between the scores of the two quizzes which are different, and that's what I get here.